we talked about the different levels of classification from domain down to species. Which is the most specific one? John? Species. How many of each species are there? How many organisms are in that?
One.
Just one. When you get down to species level, there's just one of that species, one type of living thing. So we need to just talk briefly about, well, what does it mean that two animals or plants or mushrooms are the same species? So let me ask you a question. Dogs. Is a golden retriever and a chihuahua, are they the same species?
No.
Yes.
So I hear yes, mostly I hear yeses. Does anyone think they're different species?
Wait,
Kind
A chihuahua and, what did I say, a golden retriever.
They're the same species, they just evolved.
Okay, so a lot of people earlier today, we were like, there were a few people saying, no, they're different species. And then some people saying, yes, they're the same species. So who could tell me your reason? Well, they look a lot different from each other, right? A chihuahua and a golden retriever. So give me your reasons. Why are you saying they're both the same species? Savannah?
Because they're both like their categories, like the dog category.
Okay. Well, then what if I ask you about a hyena and a dog? Same species? No. A wolf and a dog?
They come from the same ancestor.
Same species?
They come from the same ancestor.
True. How about a coyote and a wolf?
Same species.
Same species?
Oh no, coyote.
Okay. So here, this is kind of the question I'm trying to get at. So like, what makes, all those things are like pretty similar. But a wolf, a coyote, a hyena, and a dog are actually all different species. Well, you guys are correct. A chihuahua and a golden retriever are the same species. All of our modern, what we would call breeds of dogs, they're all one species. Okay? They're different sort of subtypes, different breeds, and they look different. They might have different features and maybe some different behaviors and such, but they're all one species. And there's one thing that tells us that's true. It sort of comes down to our definition of what a species is. Organisms are the same species if they can reproduce, if they can breed and produce offspring that can breed. We call that interbreeding. So can a chihuahua and a golden retriever breed?
Yes.
Yeah, there could be puppies, mixed breed puppies, like a golden doodle, a golden retriever, and a poodle. And you breed those two breeds of dogs together, and you get a labradoodle. And those are fertile, they can breed together. So dogs are one species because they could all interbreed. A dog and a hyena cannot interbreed. So even though there might be a lot of similarities, and they're both in the same family, they're not actually the same species. So if they can interbreed and produce fertile offspring, they're the same species. But there are some strange cases when you have different species that are closely related that actually can produce offspring. And we're going to talk about a couple of those. We call them hybrids. A hybrid is an offspring that's made by two different species breeding. Some of these you probably are familiar with, some you may not have ever heard of before. Probably the most common hybrid is a hybrid between a male donkey and a female horse. So those are two different species. We can see in their scientific name. A donkey is Equus asinus. Equus caballus is a horse. So they're not the same species, but they are in the same what? Genus. This is their genus, Equus. So they're both in the same genus. They're very closely related, but they're not the same species. But they can interbreed and produce a hybrid. It's something you might see on a farm. You know what it is? A mule. Yes, a mule is a hybrid. It's a common agricultural animal was used for a long time. They're strong, very durable. Mules, however, can't reproduce. They are sterile, it's called. Okay, so you can't make two mules together, male and female mule, doesn't work. They don't have offspring. The only way new mules come about is by a hybrid cross between the donkey and the horse. There are some other examples. A false killer whale and a bottlenose dolphin, two different species of marine mammals, can produce an offspring. Okay? A hybrid, it's called a wholphin.
Wait, are those things like made up?
No, they're real. Often the names we give these things come from part of each species name merged together. And you may have thought, if you saw Napoleon Dynamite, that this was made up. This next one, but it's not.
Really?
A male lion and a female tiger can produce an offspring called what? A liger.
A liger? That's close.
A liger is a real hybrid animal. Yeah, you could see them sometimes in like zoos
I saw.
or like nature attractions, and a liger is a real animal. It's a cross between the male lion and a female tiger. Again, lions and tigers are closely related. They're in the same genus, but they're different species. But a liger is a hybrid. They're really big usually. Often the hybrids of these animals are much bigger than either parent is. Okay, it's called hybrid vigor. A zebra and a horse can produce a hybrid. It's called a zorse.
I like that bad name. That was like a shaved zebra.
Now, all of these hybrids, they don't occur in nature really. These occur because in nature, species only reproduce with the same species. However, sometimes when closely related animals are kept in captivity, in a zoo, in an aquarium, sometimes they will mate and produce these hybrid offspring. But again, it has to be very close. A cat and a dog cannot reproduce. Here are some other examples. A growler bear is a cross between a grizzly, okay,
Wait,
and a polar bear.
Is that real?
A grizzly and a polar bear, yep, this is it. Again, much larger.
Oh, that's a liger cat.
This is something called a savanna cat. Have you heard of them?
Yeah,
It's a cross between a wild cat called a serval and a house cat, like a domestic cat.
Wait, like a rabbit.
One at a time, one at a time. Jenna?
I've heard stuff about scientists fusing together two animals that are completely different, like jellyfish and cat. Is that?
No, not true. No. Not to produce hybrid. Sometimes scientists can now, and we'll talk about this more in genetics, can take like a gene from one organism and insert it into another organism. But that's different than creating a hybrid animal from two parents.
I have a question.
Yeah.
What about that one like commercial, like the platypus and like the other thing? Like the platypus?
No, I think it's just made up. I don't know that commercial, but if they're not closely related species, it doesn't work.
Wait, the rabbit has like
No,
antlers.
it's just made up, yeah. Like a jackalope or something. All right, Savannah?
I've seen
I
like on TV people having like the savanna cats, but like they're not like a regular pet because like
They're kind of wild.
Yeah, they'll just
like
like
you
everywhere.
Yeah, that's true. Some people have coy dogs, like a cross between a coyote and a domestic dog. You might have heard of that. Grace?
What's it made out of?
A serval is a wild cat, and a domestic cat, like a house cat. This is a goat-sheep hybrid. Sheep-goat.
Wait, I want to watch the video.
Hold on. This is used in agriculture sometimes as an animal to get a lot of meat from. It's a cross between a cow and a bison. It's called a beefalo, and it's really big. And obviously, you can get a lot of meat from it. Okay, this is a donkey zebra mix.
on the video.
Uh-uh. And some other examples.
That's a jaguarian.
Yep. Jaguar lion. Okay, so the topic we need to really focus on today, and this is related to your homework, is this tool that scientists use that's called the Dichotomous Key. And a dichotomous key is basically a set of instructions that you can follow that can help you to identify an unknown organism. If you had a fish that you caught, but you weren't sure what type of fish it is, you can use a dichotomous key to basically figure out what species it is. If you have a tree in your yard and you're not sure what type of tree it is, you could look at its leaves and branches, follow this set of steps, and it'll allow you to identify the species of that tree. Here are some examples. These are ones I had to use in college. So like this is a key that you would use to identify the tree if you just had a twig or a fruit of it. You follow through a set of steps, and it will tell you what that came from. This is one I had to use in a botany class. This is it's called the Manual of Vascular Plants of Northeastern United States and Adjacent Canada. How'd you like to have to read this book? Actually didn't have to read it. It's more of something you use than something you read. But this whole thick thing is a key that you can basically take any plant you found, look at it, read through these steps, do what it says, and it'll help you to identify the species it is. This is one I had to use in ichthyology, the study of fish. Study of fish, and it has a key in it. So, like I was saying, catch a fish, follow through the set of instructions, it'll tell you what species of fish it is. So we are not going to use complex keys like this. This is what like a scientist might actually use. This is a key, and then it has a description of all the different species of fish. Same thing for this book on plants. We're going to look at some simplified keys, just to help you understand how you actually use them and what their purpose is. So let's look at an example here. Let's pretend you didn't know anything about these creatures, and you wanted to figure out what they were. So this is a very simple 4-step dichotomous key that would allow you to identify them. The way a dichotomous key works, it's a series of statements numbered. This just has 4 sets. Each set has 2 choices. And put those away. Put it away. I don't want to see it anymore. So the set of steps, basically you read A, you read B, and you see which one applies to this unknown creature, and then you do what it says. Either it will tell you to go on to another number, or it will tell you what species you have. So let's look at this one as an example. All right. You always start on number 1. So, tentacles present or tentacles absent? Raise your hand and tell me, what do you decide about this, Jordan?
Tentacles are present.
Yeah, tentacles are present. It has tentacles. So now it's telling us, all right, go to the second set of statements. 2A. Does it have 8 tentacles, or does it have more than 8? Somebody else. What's your decision, Rihanna?
More than 8?
More than 1, 2,
No, there's 8.
1, 2, 3,
There's
4, 5, 6, 7, 8. Actually, it has 8. So, it has 8 tentacles.
Octopus.
This is an octopus. So we've identified. Even if you never knew anything about an octopus, as long as you know basically what a tentacle is, you can use this to identify it. Let's look at this creature. Again, you always go back to the top. 1A and B. Tentacles present or absent? Raise your hand and tell me what you decide. Ava? Absent. Doesn't have any tentacles. We now need to go to 4 this time. Does it have a pair of giant claws, or does it have a pink body? Grace? Pink body? Yes. This is a shrimp. That's what a shrimp looks like. When you buy them at the grocery store, you're only getting this part. But they had a head and legs and stuff, but it's taken off. All right, let's look at this. Obviously, go back to 1. Tentacles present or absent for this one, Luke?
Absent.
Absent. We go to 4. Pair of giant claws or pink body, Luke?
Giant claw.
Giant claws. It's a crab. Last one. See anemone? Sometimes we have to go more steps. Tentacles present or absent. Who can do this one with me? Jenna, present or absent?
Absent.
Absent. Nope, sorry.
Present.
Those are tentacles. Those little things. So present. We go to 2. 8 or more than 8, Jenna? More. Go to 3. Are they hanging down or are they coming from the top?
Coming from the top.
Coming from the top. This is an anemone. So that's how we use these. Here's another simple example. We have some finches. Now this one's, you already know what these things are, so it might be easy. This one, you've probably never seen these finches before. These are their scientific names. Okay, but we can still use a key. Even if you don't know anything about these animals, as long as you can read and decide some of these things. So, let's start with this finch in the top left. Is the beak very thin, upper beak much larger than the bottom, or is the top and bottom nearly equal in size? Somebody else tell me. Luke? I'm sorry. Jordan?
B, top and bottom.
Top on nearly equal in size. Let's go to 2. Is the beak small, lower beak slightly smaller than the top? Or is the lower beak as large or larger?
A.
Smaller? I say they're about large or larger. Large or as large. So that's 3 actually. So is there a bend between the top and bottom beak? Do you see this section here? Yes, there is. This is a Camaricus finch. Let's go to this one. Is the beak very thin, upper beak, much larger than the bottom, or are they about equal in size? Who can do this one? Grace?
Oh, wait, no. B.
Beak? Equal in size. 2. Is the beak small, lower beak slightly smaller than the top, or is the lower beak as large or large? Wait, did I do that right? Yes. What do you think?
A.
A? Geospiza finch, yes. Let's do this one.
Why did I guess this one?
Let's see. Brandon? 1. Beak very thin, upper beak much larger than bottom, or about the same size? B, same size. Go to set 2. Is the beak small, lower one slightly smaller than the top, or lower beak as large or larger? B. Go to set 3. Is there a bend between the beaks, or is the lower edge mostly flat? B. This is a Platyspiza finch. And then the last one, Jenna, is the beak very thin, upper beak much larger than the bottom, or are they equal in size?
A.
A. This is a Certhedia finch. Yeah, you can, so you know what it was. So that's how you use these dichotomous keys. Any questions about how to do that? Brendan? No. Your homework's going to be to use the key, yes. All right, this last one.
Oh, no.
So we have some creatures here. We have this is a little bit of a longer key. And so it works the same way, it just takes a few more steps. So let's look at this animal.
I have these little gizmos.
Yeah, so we didn't call them gremlins because that would be a copyright violation. These are norns.
My hamster's name is
Really? All right, so let's look at this one and identify, then I'll let you work on your own. So let's look at this. We always start back at number 1.
Wait, is this the practice?
This is practice.
Wait, I don't.
Hold on one second. Let's just do this first. So, does it have pointed ears or rounded ears? Raise your hand if you can help me with this one.
The first one?
Yeah, Sophia?
Pointed.
Pointed. The ends are pointed. So, what do we do? Go to 3. Do its ears point up or straight to the side, or do they point down?
Straight to the side.
Straight to the side, I go to 5. Is it engaging in waving behavior or not?
What do you mean?
Like this, like,
No.
no,
No.
it does not. Go to 6. Does it have hair on its head?
I can't tell either.
That white stuff is hair.
Okay, so yes.
Yes?
Oh, it's a.
This is a Bradleyus norn.
I didn't know it was a brand new.
So we basically just follow the steps until it tells us the actual name. So what you're going to do is you're going to finish up doing the rest of these 7. When you have done that, you're going to come check and see that you got it right. Make sure you understand how to use this key. And then you can take your homework. Your homework is basically to use a dichotomous key to identify these aliens and give them their name. Okay? So it's basically the same sort of thing, just as practice so we understand how to use the key. So finish the norns, check that you got their identification right up here, then you can take your homework and you can get started on it. 1 second.